Okay, this is IM2 12.4 homework. We're going to factor these. This is probably the first time that you're seeing factoring. Let's take a look at number one. We'll zoom right in here. Here's number one, and we need to factor that. Well, factoring is all about, well, in some cases, the greatest common factor. Can you think of a number, or even sometimes an expression, that divides into each one of these terms? What do they have in common? A 6. So here's an easy way to do this. If you know that the GCF is equal to 6, you can take each one of these terms and divide by it. So help me out here. What is 6x divided by 6? X, 1x, right? Now what is negative 24 here? Negative 24 divided by 6. Negative 4, all right? Now, don't forget about the 6. Because we want to factor, we are going to surround this with parentheses, and that 6 is going to come out front. This is now in factored form. Now, you can always test factoring because you can try to redistribute and make sure you get the original expression back. Watch. If I redistribute, tell me what we get here. What's 6 times x? And 6 times negative 4 is? Negative 24. Folks, look what we just did. This should make sense. This should make complete sense. Distributing is really the multiplication operation, right? When you distribute, well, knowing that distributing is multiplication, what do you think factoring is? It's dividing. You are dividing by a GCF here, yes. That's truly what it is. Let's move over to number 2. Okay, we can kind of speed this up. I would think it's pretty easy now. What do they have in common? Number 2. 3. Divide by 3, divide by 3. And I have now x plus 36 divided by 3? 12. Don't forget, though, we want to bring that 3 out front. Right, moving along, let's go to number 3. What do they have in common? 5. 5. We have now 2x plus 3. Surround it with parentheses. Bring your 5 out front. There it is, factored. Right, let's head over to number 4. What do they have in common? Number 4? 7. Okay, if I divide by a 7 and I divide by a 7, looks like I'm going to have 6x minus 5. Surround with parentheses. Bring your 7 out. There it is in factored form. Yes? All right, number 5. Take a look at this one. This is a little different. When we want to factor something in number 5, we're starting out with a negative. So it would be nice to have this coefficient before the x be a positive. So I would just divide each one of these by negative 1. Okay, the same kind of thing happens here. What is negative x divided by negative 1? X. And then negative 9 divided by negative 1? Plus 9, and then bring the negative 1 out. There it is in factored form. And technically, it's fine with how they present it here, negative x minus 9, but we factored out a negative 1. It's very useful in some cases. Yes, Preston?
Putting negative 1, can you just put a negative sign?
Certainly. You don't have to have that negative 1. You can just have that negative symbol right there. Certainly. Look at number 6. Let's head over to number 6 here. How about I divide out, what do you think, a negative or a positive? I'm going to divide out a negative 2. Negative 2, we'll factor that out. So we're going to end up with here, looks like x, and then minus 7, and the negative 2 will come out front. Good, good. All right, very important here, the next instructions. It says, determine the x-intercepts of each quadratic function in factored form. What you're seeing right here, this is in factored form. This x minus 2 is factored, and this is factored. Now, I want you to think about this for a moment. This is difficult to understand, okay, for the first time seeing this. Let's just take, for example, this is an aside. 20. Let's just take the number 20. Can you think of factors for me of 20? Go ahead. I just want to generate a short little list of them. Yes. 20 times 1 gives you 20. Good. Another one. 4 times 5. 2 times 10. Good. And that's enough. Folks, these are factors of 20. What do you do with factors? You multiply them. So there's a direct relationship here. We're multiplying x minus 2. This is a binomial times x minus 8. These are factors. When you multiply them together and you do what we call FOIL, or the distributive property, you get a quadratic in standard form. This is just in factored form. Watch carefully. Now I'm going to do something that they're not even asking. This is just for your understanding. Help me out with this whole FOIL thing, with the distributive property. I need to zoom in for this. All right. Watch this. Please tell me what x times x is. X squared. Good. I'm going to color code this so you can see. That was the first term in each binomial. Now we're going to do the outside. What is x times negative 8? Minus 8x. All right, next one, let's do the inner. Negative 2 times x is? Minus 2x. And finally, what's negative 2 times negative 8? Plus 16. All right, I'm going to bring this down. This is f of x. One more time here. F of x is equal to, if you notice, see here, aren't these like terms? These are like terms, so I can go, this can be x squared minus 10x and then plus 16. This is absolutely not what homework is asking you to do, but I want to just point out that this is in standard form, and we actually, I want you to see that this first piece here, the way they're writing it is in factored form. Now, both of these, they represent the same function. They're a quadratic. What kind of shape do you think it's going to be? It's going to be a parabola. Yeah, they're both quadratics. And, very importantly, do you see this coefficient before x squared? What is it? I don't see anything there, but what is it? It's actually a 1. Yes. Let's make sure we write that in a different color here. There's a 1 there. Since this 1 is positive, guess which way that this parabola is going to open? Up. Absolutely, it's going to open up. All right. Now, I need to erase a little bit of this because I need to generate some room. So, at least right now, you can see that this factored form can be represented in standard form, and they are actually the same. So, I want to do some erasing. Please tell me, listen to my next question. If I wanted to find x-intercepts, what do you plug in for y? 0. Okay, did you hear that even in the recording? If you're going to find x-intercepts, you plug in 0 for y. But I don't even see a y. Where is there y up here? F of x. Good, yes. So watch this. Our goal right now, we are going to find x-intercepts. Got it? Now, listen to this. I want to do some highlighting here. Let's make this one yellow, and let's make this one green. If you multiply two things together, something times something gives you 0. Well, what do you know one of them should equal then? One of them has to equal 0. So watch, we either have x minus 2 is going to equal 0, or x minus 8 equals 0. One of them had to equal 0. Do you agree? Now, add 2, add 2. X equals 2. Add 8, add 8. X equals 8. Folks, guess what you just found? X-intercepts. This x-intercept right here in ordered pair form is 2 comma 0. 2 comma 0. Okay, how about this one? 8 comma 0. Ultimately, you guys are going to get so good you don't even have to show any of this work. Watch this. Let's go to number 8. And what I want you to do is tell me whether this is in factored form. Is number 8 in factored form? It certainly is. Now, yep. Okay, so we're focusing on this. I want to find x-intercepts, right? Can you do it in your head? What are they?
-1.
Oh, good, good. Look, you look at the positive one and you're like, oh yeah, if we actually plugged in 0 and solved, then this would be -1 comma 0. There's your x-intercept. How about from this one again? 6 comma 0. Do you see how it's going to be, in this case, the opposite of each one of these values inside the binomial? Yes, good, good. All right, let's take a look over here. Take a look at 9. Okay, they're going to try to throw a wrench in the works right now. They're going to try to fool you by putting a 3 in here. Does that matter? No, it doesn't matter. It doesn't matter at all when you're finding x-intercepts. Okay, listen to my next question. Would anyone like to see why? Why it doesn't matter? Okay, watch. Okay, bear with me for one moment. I need to erase this, and I want to bring this onto a separate page. So we're going to take this. I need some room here. All right. I didn't copy so nice, but that's all right. Okay, you can. Anyone can just tell me the answer as I'm asking questions. What do you plug in for f of x if I'm finding x-intercepts? 0. 0 equals 3 times x plus 4 multiplied by x minus 2. We're okay with that? Okay, I have 3 things that I'm multiplying together. I have a 3 times this times this. One of those has to equal, one of them has to equal 0. So we have options here. Well, either 3 equals 0, or x plus 4 equals 0, or x minus 2 equals 0. Can 3 equal 0? No, that does not help us find x-intercepts. It just can't equal 0. It doesn't help us at all. These two help us, the x plus 4 and the x minus 2. When you solve these, minus 4, minus 4. Make sense? So we've got -4 comma 0 and plus 2, x equals 2. That's 2 comma 0. You do not have to multiply by 3. Not at all. Not at all. This is, yes, this 3 does not help when you're seeking out x-intercepts, when you're finding them. That 3 has another special characteristic, and that is coming in section 12.7, but I'm going to allude to it right now. That 3 is called our vertical stretch factor. What that 3 does is it takes our parent x squared function and changes its height by 3. Okay? So what's my point? If you look at a problem like this, you immediately know the x-intercepts are -4 comma 0 and 2 comma 0. Let's move over to number 10. Guys, look at number 10 up here. Does the 0.25 do anything for us if we're seeking out x-intercepts? It does not at all. So what are my x-intercepts up here then? What are they? 1 comma 0 and 12 comma 0. Yes, very good. And you're going to have a calculator with you. So all you have to do is plug this thing into the calculator and you immediately know what the x-intercepts are anyway. Watch. If I take this calculator out, y equals, we'll clear this out, I can enter it like this, 0.25
open parentheses, x minus 1, close parentheses, open them up again, and this is going to be x minus 12, close parentheses. And if you graph this, zoom, and let's do number 6. You're not going to see it all because it's a 10 by 10. Watch, you're not going to see it right there. So what we'll do is let's change the window and let's go with an x max of like 15. Now graph. Now watch this. Please tell me what those x-intercepts look like. You see them? This one is 1, 0, and that one is 12, 0. Now, I want to address this. Some of you are thinking, why is the 0.25? Why does the 0.25 out in front, right here, why does that not make a difference? Watch this. Y equals, if I come down here and I just enter x minus 1, close parentheses, open parentheses, x minus 12. Okay, they're almost identical, right? Except for the second one doesn't have a 0.25. Now watch. That number out front changes the height. It's a vertical stretch factor. Does it change the x-intercepts? Not at all. Okay? This 0.25, I could put 300 million right there. And it really doesn't matter. It's still going to go through 1 and 12. All right. Number 11. It says, write a quadratic function in factored form with each set of given characteristics. Okay, very crucial. Here we go. Write a quadratic function that represents a parabola that opens downward. If you know it's going to open downward right here, then you know that what sign is in front of the squared term. It's going to be a negative out front. And it has x-intercepts of -2, 0, and 5, 0. So look, we have this, here's your form. We have a times x minus p times, let's say, x minus q. That's the standard, that's the factored form of a quadratic. All right. Here we go. Y is equal to. Please tell me what the a value is. The easiest a value, if you know this thing is going to open down. -1. You can put negative anything right now, but we're going to keep it easy and just go -1. And then we have x minus something, and then x minus something. Okay, please tell me, look at this. This is -2, 0. How is this going to affect this number right here? X, it's really x minus a -2, which becomes x plus 2. Good. All right, look at this one. This is 5, 0. So this is going to be x minus 5. And you just created it. And it didn't ask for it in standard form. So you can keep it in, and what's this form called again? Factored form. You can keep it just like that. Yes?
Do you want us to put -1 or a is less than 0?
You could put a is less than 0. I would just put a -1 in because they're asking for a quadratic. Doesn't matter. You could put -1,000 there. Doesn't matter. Hey, let's take a look at number 12. 12 is asking us, write a quadratic function that represents a parabola that opens upward with x-intercepts. Okay. Y equals, you know your a value, your vertical stretch factor, that's what that is out front, is going to be, it's a positive. Who cares what it is right now? It's a positive. All right, so I've got these parentheses. Okay, so x, what's that going to be? X plus 8 and x plus 1. Awesome, yes. All right, now, number 13 says determine the x-intercepts for each function using your graphing calculator. Write the function in factored form. Let's
So we want to make sure we do this. We want to determine x-intercepts, and we want to use the calculator to do so. Then we want to write this thing in factored form. There's a lot going on here. So they're really teaching you a different approach. They're going to teach you how to factor by using your calculator. We usually don't do this. We do it all by hand. But for you guys, maybe you're lucky, I'm not sure. Here we go. Y equals. Clear these out. You can follow along if you want. Let's do number 13. All right, and I want to zoom in here so you can see it. So this is going to be number 13. There it is. It's going to be x squared and minus 8x and then plus 7. Go ahead and graph. So I'm going to do zoom 6. That's going to give me a 10 by 10. And I'm going to immediately be able to factor this thing. Watch this. Okay, pull this over. Let's shrink it down. Put this right here. Please tell me what this x-intercept looks like. 1 comma 0. All right, how about this one? Looks to me like it's going to be out to, here's 1, 2, 3, 4, 5, 6, 7. That's 7 comma 0. Do you think you can write this? Yeah, you can write this in factored form. It's going to be the following. Y is equal to x minus 7. Fine. We can do that one first. And then x minus 1. Yes. Very good. Hey, what's the vertical stretch factor in this one? Just, this is supposed to be 12.7, but we're kind of moving ahead. It's 1. Yeah. Vertical stretch factor is right here. It's 1.
Is the vertical stretch factor A?
Yeah, it's the A. Yep. All right, I'm going to do, we'll do 14. Here's 14. Y equals. Let's clear this out. We've got 2x squared minus 10x. And then minus 48. We'll go ahead and graph this thing. Hey, while this is graphing, do you think every x-intercept is going to be wonderful and beautiful, a nice integer? Not all the time. So sometimes you'll have to use the 0 button up here. Okay? Yes, question?
Is there an easier way to do this?
Yes, there is an easier way. You can do it all out by hand if you are good at factoring. You don't even need to use a calculator. But in this case, yeah. In this case, we're kind of depending on the calculator for now. Okay, to me it looks like I have a x-intercept of negative 3 and 1, 2, 3, 4, 5, 6, 7, 8. Negative 3 and 8. So negative 3 comma 0 and 8 comma 0. What is this thing going to be in factored form?
X plus 3.
You know what, I want to check something. What was this? Yes. Hey, on the last one, I know that I just deviated. I'm really sorry about that, but look at this. This was a 1, therefore this has to be a 1. Both of those vertical stretch factors have to match up. All right, we move over. Here we go. Ready? Let's write it as f of x. That's the name of this function. Equals. Let's write the parentheses first. Okay, from negative 3 comma 0, what's that going to become? X plus 3. Then? And then x minus 8. Okay, now watch. Please tell me what should be right here. What should be right here? 2, yes. Hey, you want to know how to cheat? You want to know that you did this correctly? Watch this. Head over to the calculator. Step down. Guess what I'm going to enter here? I'm going to enter the factored form and make sure that it graphs the same exact parabola. Here we go. 2 multiplied by a set of parentheses, x plus 3, close them up, then open x minus 8, close them up, graph. You better get the same thing. Watch, it's going to turn colors on me here. Did it? And there it is. They are the same parabola, therefore you factored it correctly. Yes? Yes. Hope so. Okay, we have kind of fast forwarded to number 17. Number 17 is asking us to determine the x-intercepts and then, if necessary, write the function in factored form. All right, there's a couple ways to do this, but here goes. We want to find the x-intercepts. So what do you plug in for f of x if you're going to find x-intercepts? 0. So we go 0 is equal to the product of 3x plus 18 multiplied by x minus 2. Either this is going to equal 0 or this is going to equal 0. Got it? So we go 3x plus 18 equals 0 or x minus 2 equals 0. How do you solve this? Minus 18. 3x is equal to negative 18. Divide by 3. X equals negative 6. Hey, I just found one. That one is negative 6 comma 0. Could you have found it just by graphing it? You certainly could have. This one over here. Add 2. Add 2. X equals 2. Now they're asking you to write this top function here, this f of x, in factored form. So this is 2 comma 0. Watch, I'm going to put this factored form right inside here. So f of x is equal to, first look at both of your x-intercepts. Okay, so this is going to be a set of parentheses and a set of parentheses. Okay, with negative 6 comma 0, what does it give you right here? X plus 6. Okay, 2 comma 0, what does that give you right here? X, not plus 2, but minus 2. X minus 2. Now, what am I forgetting? What did I not do yet? 3. The 3 has to be out front. That's in complete factored form. Now, did you have to do all of that to write it in factored form? No. You could have just, right in the beginning right here, taken and divided 3 here, and just divided out a GCF if you wanted to. Let's move to number 18. Ooh, look what they did to us. Look what they did. I'll tell you, but this is tricky. Anyone have an idea even before I start talking? Yes?
They, for the 3 minus x, they flipped it.
They flipped it, right? So watch this. Do you agree I could rewrite it like this? You tell me if I am breaking any math laws. Is 3 minus x the same thing as negative x plus 3? Is that the same? Absolutely the same, right? But a negative is out front. What do you think I need to do?
Put the negative out of the parentheses.
I could factor it, or I could right now find. I could use the zero product property and set each one equal to 0, right? You could divide by a negative also. So there's multiple ways to do this. Oh, I'm missing a set of parentheses. Here we go. Okay, here's one way I could do it. 0 equals x plus 8 times negative x plus 3. Okay. I can find these x-intercepts by using the zero product property. Here, let me write that here. Zero product property. We have x plus 8 equals 0, or negative x plus 3 equals 0. Solve each one of these. That's negative 8 comma 0. And this one? Negative x equals negative 3. Therefore, x is equal to 3. Here it is. 3 comma 0 is your x-intercept. All right, so bear with me. I need to kind of, let's shrink this down a bit.
something's not working there. All right, I'll just write it off to the side. In factored form, what is this going to look like in factored form? Well, f of x equals, we have two sets of parentheses here. We're going to have x plus 8 and x minus 3, but what's going to come before it? Do you see it at all? What's going to come before it?
Negative.
Yeah. This is a negative, and you can factor out that negative. So it's going to be a negative 1. That's the trickiest part so far today. Do you agree? You want to see it a different way? You do? I'll show you a different way, watch. All right, here's a different way. Okay, hopefully this is going to make sense, watch. I have f of x is equal to x plus 8, and then what I'm going to do is I'm going to rewrite this again, negative x plus 3. Now watch. F of x is equal to x plus 8. Now I'm going to divide out a negative here. Write my parentheses. Now help me out. What is negative x divided by negative 1? Come on. X. What is 3 divided by negative 1? Minus 3. But now what do you think has to come out front? A negative 1 has to come out front because we are dividing it out. We're factoring it. So the negative 1, look, watch this. I'm going to use some fading ink. The negative 1 could be right here, or it could be right here, right out front. Which one do we prefer?
So the second one. So whatever is the farthest to left.
The farthest to the left, yes. So it should be out front of both binomials. So we're going to rewrite it as f of x is equal to negative 1 times x plus 8 times x minus 3. Does that make sense? Hey, once again, how can you test this and make sure you're correct? Yes?
Put it in the calculator.
Just put it in the calculator. Make sure that it produces the same parabola. So what I see that I'm going to do here is I see that I can factor out a greatest common factor here. What number do you think I'm going to factor out here? Shout it out. It's fine. Not just a 2, but a negative 2. So here's my plan. I'm going to divide by negative 2, divide by negative 2. Now I'm going to start rewriting this. F of x is equal to negative 2, because that's what I'm factoring out now. What's negative 2x divided by negative 2? X. Then, what is 8 divided by negative 2? Negative 4, close parentheses, now just bring down your x minus 14, and look what happens. You can immediately find x-intercepts. Look, what's the x-intercept from this? From here. Piece of cake, right? What is the vertical stretch factor? Negative 2. That means, since it's negative, it's going to open down. Yes.
Wait, so when a whole number is like in the parentheses with x, you have to
Factor out a negative, yes. Yes, try to. All right, let's move over to number 20. Okay, I think we're doing well here. Hey, tell me whether or not I'm going to write this correctly. Am I breaking any rules? Ready? F of x is equal to 2x plus 16 multiplied by x plus 16. Is there anything wrong with swapping their positions? No, that is because multiplication is, what's that? Product commutative. Yes, very good. Multiplication is commutative. You can multiply in any order you wish. Okay, so it doesn't matter. Now, can I factor out something here?
2.
Yes, let's factor out a 2. We have now f of x is equal to 2 multiplied by x plus 8, and then x plus 16. Okay, shout it out. What are the zeros? What are the x-intercepts?
negative 8, comma 0, and negative 16, comma 0. Okay, turn to your neighbor right now and tell them how you can check it. All right, we're at a point where we're going to cover a critical problem. It says the Squeaky Clean Car Wash charges $20 for its deluxe wash. At this price, the car wash averages 200 customers per day. The car wash has determined that for every 25 cents they decrease the price of the wash, they will see an increase of 5 customers per day. So, let's begin filling this out. First, they give you a table, and this table does help. What is the price of a car wash at this initial, or the number of price decreases? Let's say there are 0 price decreases. Hasn't gone down yet. What's the price? $20. How many customers? 200. Now, revenue. Now how do you find revenue? Folks, just think about this logically. If you're giving 200 customers a car wash at $20 per car wash, what do you do with these two? You multiply them, right? And when we multiply them, that's going to be 4,000. Now let's start going through this process of reducing the price. We're going to reduce the price once, but we're going to reduce it by how much? 25 cents. So what's this going to be now? 19.75. Yes, very good. Now it says if we reduce that price, we're going to increase the number of customers by 5. So this is going to be 205. When you multiply those two together, you're going to get 4,048.75. All right, I want to save time in this video here. We'll do one more line here. Now, if we decrease the price 4 times, that means how much have we reduced the price altogether? $1. So we're going to go down to $19. That means that the number of customers is going to decrease by 4 times 5, which is 20. How many customers now? 220. Okay, we're increasing the number of customers. When we multiply those two to find the revenue, it's $4,180. $4,180. Okay. Do you want to do one more row? Let's do one more. Okay, this states here we are going to have 15 price decreases. That's 15 times how much? That is, yeah, we're going to do the following. Look, we're going to take the 20 from up top. We're going to take that 20 and we're going to subtract 15 groups of 25 cents. Does that make sense?
Yes.
All right, so that's going to be $16.25. And you can see here, I want to highlight this, it's important. This is really kind of how I arrived at $16.25. Number of customers. Well, I started with 200, but I'm going to add to that because I'm increasing this 15 times 5, yes. All right. Now, that is going to be, I believe, $275. When you multiply those together to find the revenue, okay, we're going to multiply these together. 275 people received the car wash at $16.25 a piece. That's going to be
4468.75.
all right, 4468.75. Now, kind of as we scroll down through, if we bring this, just imagine that we did fill out all of these. Look what we have.
And please focus on the following. Focus on what I highlighted right here. Let's think about what this is going to be. If I have n decreases in price, how am I going to figure it out?
20 minus 0.25.
20 minus
0.25.
0.25 or
0.25.
0.25 times
And
n. Yes. You kind of see how it kind of falls into place, right?
For each one.
Next one is going to be, well, we start with what we originally had here, 200 customers, and we're going to add to that
5 and 3. Yeah.
5 times n. All right, let me circle both of these. These are important. Please tell me what you do with those two expressions to find the revenue function. Okay? Yes?
Multiply that.
You multiply them. Yes, you're going to multiply them. And here's what it's going to look like. We have two sets of parentheses. I'm going to have to really write nice and small here. That means, let's do this. Let's zoom right in. A little easier for me. This is going to be 20 minus 0.25n multiplied by 200 plus 5n. Do you think you have the skill right now to multiply that out and write it in standard form if you wanted to?
Yeah.
Certainly could. Yes. All right. Part B. Part B says the manager of the car wash thinks that he should just keep decreasing the price to bring in the most customers. Based on the table, is this a good decision?
No,
Why not?
because it's revenue, not profit.
It's revenue, not profit. Okay. Yes.
Because eventually the graph's going to turn on him and it's going to start losing money.
Yeah, eventually they'll start losing money, right? There, somewhere here, we're going to maximize the revenue, right? Somewhere. Well, I would think, let me just make sure. This is going to be a big no. Okay? We want to find how many price increases, okay, yield a maximum revenue. So how many price decreases yield a maximum revenue? And we're going to do that probably in a few moments. It says here, write a revenue, here, let me make sure you're following. Write a revenue for the car wash as a function R of n, R in terms of n, in standard form, then identify A, B, and C for the function. We could do that. Where am I going to start? Let me pause this. So R of n, R in terms of n is equal to, look up here.
That's the factor form.
This is the factored form, so I'm going to bring it down. So we're going to go with 20 minus 0.25n times 200 plus 5n. Guess what I'm going to do to this thing? I'm not going to factor it, but I'm going to distribute. We call it FOIL. How many of you, FOIL is brand new? The whole term FOIL, this whole thing. Okay, watch. I'll really explain this thoroughly, and I'll use some different colors along the way.
Wait, on our paper it says standard form.
This is not standard form.
It says factored form.
Oh, yours says factored form?
Yeah, on C, it's factored.
Ah, okay. This one says standard form.
same here.
No, it says
So,
No, it's factory.
all right. Well,
I printed it out.
here, let's do this, even for the recording. Some students are saying it should end in factored form, some standard. Why don't I just write it in standard form so we have both? Here we go. I'm going to multiply the 20 times 200, and that's going to be the F in FOIL. Keep in mind, we have F, then we have O, then we have I, and then we have L in this whole idea of FOIL, distributing. Yes?
Okay, I see it on the with packets, it says in factored form, but if you printed it out and did the homework, like from online, it says in standard form.
Yeah, I believe it's been changed. Okay, no worries. All right, let's do the outer. The outer would be 20 times 5n. That's the outer two terms. The inner is going to be in green. This inner are these two. And the last is going to be this one multiplied by this one. That's the last. Can you see how that's going to result? Okay. And really, in this case, if you're going to maximize, okay, there's no need to write it in standard form, but we can go through and do that. Here we go. R of n is equal to, please tell me, what is 20 times 200? 4,000. I want to make sure that we're color coding here. This is going to be the 4,000. Now, let's go with the outer. Okay? This outer is going to be 20 times 5n. That's going to be 100n. All right, so that's going to be in purple, plus 100n. Next, we're going to be dealing with the inner, so green, minus 0.25n times 200. What is 0.25 times 200?
50.
50, yes, very good. But it's going to be a minus 50n. And finally, in blue, 0.25n times 5n. What's that going to be?
Minus 1.25 n.
Yes, very good. Minus 1.25n squared. Now, if you're going to write this in standard form, watch carefully. You want the degree of the function, the largest exponent, to come first. So R of n is equal to negative 1.25n squared. Then, look at these two. These are like terms. 100n minus 50n is 50n. So we'll go plus 50n, and finally, plus 4,000. That, folks, is in standard form. There it is. All right, part D says, based on the equation, will the graph of the revenue function open up or down? What do you think? It's going to open downward, yes, because of this leading coefficient is negative. So it's going to open down. All right, moving ahead. You'll notice we want to graph this thing. So I'm going to go ahead and go back to this page here, and I'm going to graph this. And I can just graph it in factor form. Here we go. Y equals. Let's clear this out. Let's clear this out. Head up here, and I'm going to enter it in factor form. So open parentheses, 20 minus 0.25x, close parentheses, open parentheses, 200 plus 5x. Any ideas for windows? We probably need a decent window, right? So let's go window. X max. What do you think the X max is going to be? That's N, and that N is the number of price decreases. So what do you think that's going to be? Maybe 100? Yeah, and how am I getting that? Some people are shouting it out. Look, here is your independent variable, your N. And you'll notice the table is going up to 75, so we can just go up to 100. All right, let's head over here. Y max. What is your output? What are we getting? We're getting, yes? Sorry. There we go. There's a 100. Okay, Y max. 5,000? And let's go ahead and graph. There it is. Okay. Now, guys, if you're asked to graph on your test, you're going to need to get some very important characteristics here. What are they? Let's first find, how about the y-intercept? If you're going to find the y-intercept, look at this. On this page, where is your y-intercept? Can you see it at all? You can shout it out. It's okay. It's okay to be wrong. It doesn't matter. Max, say it. 4,000. Folks, in standard form, this last number is always your y-intercept. Every single time, it's your y-intercept. So on this next page, I can go up to, let me zoom in a little bit here. I can go up to 4,000. Put a little point there. Let's find the maximum. I'm going to head over to my graph, and let's go second trace. Let's calculate the maximum, number 4. Enter. Enter, enter. There it is. So it looks like it's at 20, 4,500. All right, let's follow that over here. So we're going to go with 20, and then 4,500 is about right here. Okay. What other point do you think I'm going to get? Well, check this out. You want to know a nice way? Head over to second table, and then you've got all of these values. And if I want to start back at 0, I can go with, how about second table set? Still going, I hit it so many times there. There's second table set. I can start at 0, and then go back to table, and now it starts right at 0. Look at this. Look at all my points. Yeah. Now, once again, how do I get, like, how about right out to, let's say I wanted 40. What could I do? Yes?
Second table set 40.
Second table set. Go right to 40, right? Then go second table, and there it is. 40, 4,000. All I have to do is this. Look. 40, 4,000. Add up 4,000. There it is. How about we find at 50? Look, there it is. 50, 3375. All right? 50, 30. Tell me when to stop. Probably about right here. Okay, maybe a little high, right about here. What other point can I get? How about I get the x-intercept? I find the 0. So we head back to the graph. And let's go second calculate. Let's find the 0, number 2. All right, there's my 80, 0. All I have to do is put a point here, and then I don't know about you, but that's looking good. It's good. Okay. Our next goal here, it says, at what number of price decreases will the revenue be maximized? What is the maximum revenue? Folks, where do you find that maximum? At the max, yeah, it's what's called the vertex of this parabola. And we did find it already. It is right here. And that happens to be what? 20, 4,500. So 20, 4,500, right? There we go. 20, 4,500. That would mean, what's the 20 represent? 20 price decreases.
So 20 price decreases. And the 4,500 would be the maximum
Maximum revenue in dollars.
max revenue. All right. G says, what should the price be to maximize the revenue? How many customers will the car wash see at that price?
And then plug in the two expressions.
Yeah, you're going to have to plug them in. You're going to have to plug in what? So you're going to let n equal 20. If you let n equal 20 right here, okay, when you go through all of this this work, okay, coming back to this video right now, at the end of the day, we're working on G here. It says, what should the price be to maximize the revenue? Okay, so we're worried about, we're wondering what the price will be, and then how many customers will the car wash see at that price? Show your work. I'm hoping that you can understand that in our R of n function, in factored form, this part here was dealing with the price. Okay, this was the number of price reductions. And that this 200 plus 5n was our number of customers. And what we found was the maximum revenue, the maximum amount of money that we were going to make was $4,500, and that was with 20 price reductions. So what I'm going to do is I'm going to plug 20 in to find the price at which we make the most money. So when we plug 20 in, let's go ahead and figure out what that is. We'll open up our calculator. Here we go. That's going to be 20 and then minus 0.25 multiplied by 20. That's going to be 15. So there's your price that's going to produce the most revenue. And then the number of customers, well, let's figure out what that is. You'll notice what I'm going to do is, right here, I'm going to calculate this. 200 plus 5 multiplied by 20, and that's 300. All right, so this just means that the price is going to be $15. There'll be 300 customers. When you put these two together, multiplied together, that will give you the 4,500 for the maximum revenue. All right, let's move down. It says here on this next line, determine the x-intercepts of the revenue function. Explain what they mean in terms of the problem situation. So keep in mind, this is what I just graphed. All right, if I open up the calculator, put up into y equals, this is what I graphed. So you can kind of see I have multiple windows open here, and this is so that you can follow along on your own calculator, right? So let's make sure that you can see everything here. All right, so you can see what I set my window at. All right, you can see this is in factored form, and here is my quadratic or my parabola. It's asking for x-intercepts and explain what they mean. Here are the x-intercepts. Let's highlight them. Here's an x-intercept and here's an x-intercept. All right, let's talk about this 80, 0. Really, the 80, 0 just means, well, 80 would be the number of price reductions. So when you reduce the price 80 times, okay, 80 times at 25 cents each reduction, well, the revenue is going to be 0. So you're not going to make any money. You've reduced the price so much that you're not going to make any money. Now, when we come over here, this negative 40, 0, This negative 40 would mean that you're going to reduce the price negative 40 times, and that really doesn't make any sense with this problem. So it indeed, I mean, it's still an x-intercept. It's a mathematical x-intercept, but this is the one that really means something in the context of the problem. Okay. So once again, 80 price decreases, and the revenue would equal $0. Moving to part I. Part I is asking us to determine the y-intercept of the revenue function and explain what it means in terms of this problem situation. All right, well, why don't we go ahead and look, let's look up here again. This y-intercept is right here. You can see my cursor. That happens to be 0, 4,000. So what does this mean, this 0? Remember, this is n, comma, r of n. So the 0 means n, that's the number of price decreases, and r of n means revenue. So if you keep the price as is, no price reductions at all, then you're going to have a revenue of $4,000. So we could say for I, at 0 price decreases, the revenue is equal to $4,000. And there you have it. And that is the end of our section 12.4 homework.